So in today's experiment, we're going to be taking a look at a reaction known as a saponification reaction. And what that involves is the hydrolysis of an ester under basic conditions. This type of a reaction is used very frequently to make different types of soaps. So essentially what's going to be occurring in the reactions today is we're going to take an oil or a fat that contains one or more ester bonds, and we're going to break those bonds under basic conditions using sodium hydroxide as the base. And as a result of that reaction, we're going to end up with the salt, or the carboxylate salt, which is the soap, and then we also get an alcohol as the other product in the saponification reaction. So I've gone ahead and I've measured out approximately 5 grams of olive oil, and I've actually recorded the exact amount, 4.88 grams of olive oil. And as you'll notice, olive oil is very liquidy. And it has that physical state because of the type of hydrocarbon tail that make up the olive oil itself, right? There's a lot of cis double bonds in the hydrocarbon tail that don't allow close packing of the molecules. So as they're more spread out, they tend to be more like a liquid. So olive oil is our oil that we're using here, and there's 4.88 grams. So to the olive oil, I'm going to add 15 milliliters of ethanol together with 15 milliliters of sodium hydroxide. All right, so I'm going to measure out approximately 15 mils of the ethanol solution. I'm going to add that to my olive oil. Then I'm also going to add 15 milliliters of 20% sodium hydroxide. So about 15 milliliters, we add that to the olive oil as well. So a couple things to notice when I added the sodium hydroxide and the ethanol to the olive oil, you notice that there are 2 layers that form. The top layer that looks a little oily, that's the olive oil itself. Olive oil tends to be a little less dense than the solution that it's in right now, so it's going to float to the top. If I swirl it around to get it uniformly mixed, eventually it's going to separate back into those 2 layers. So what we're going to do is to apply a little bit of heat and stir this constantly over some heat to make sure that we allow the reaction to go to completion before we continue with the next steps. So in order for that process to go more efficiently, I'm going to add a stir bar to the olive oil, and I'm going to place it on a hot plate. I'm going to turn the heat up, and then I'm also going to turn the stirrer on to get everything evenly mixed. And I'm going to cover this with a watch glass. And I'm going to let that heat for about 30 minutes or so until I see that the layers no longer separate, and that's going to tell me that the saponification process is complete. Okay, so after about half an hour on the hot plate with the stir bar, you can see how the olive oil has actually changed after it's been combined with the sodium hydroxide and the ethanol. Instead now of the mixture separating into a couple different layers, everything is uniform and homogeneous right now. Right, so that kind of tells us that our process is complete and we can go ahead with the other step. So we are carefully going to remove the beaker with the olive oil on it from the hot plate, and we're going to pour it into our sodium chloride solution that we made previously in order to salt out the soap. So carefully and gently grab a hold. And as I poured it into the sodium chloride solution, what you probably notice is that first of all the color changed to a yellowish color, but then what you also would notice here is that there seems to be some solid being produced. Right, and that solid material is actually the soap that has been salted out of this solution. So I've measured out here in this beaker approximately 5 grams of a fat vegetable shortening, and I've recorded the exact amount. It's 4.85 grams, and what you will notice in comparison to an oil, for instance, this vegetable shortening is actually a solid rather than a liquid, and that's due to the types of hydrocarbon tails that are in the fat itself. So in a fat, the hydrocarbon tails are saturated, meaning that they all have carbon-to-carbon single bonds, which allow those tails to pack really, really close together. And as a result, the closer those molecules pack, the more like a solid that substance is going to be. So this is our vegetable shortening, just under 5 grams, and it's going to start off as a solid. So to that vegetable shortening, I'm going to add 15 milliliters of sodium hydroxide, as well as 15 milliliters of ethanol. So I'll just measure those out carefully. So we have 15 mils of the sodium hydroxide solution, and we're going to also provide 15 milliliters of ethanol. We're going to add those to the vegetable shortening. We're also going to add a small stir bar to this. We're going to cover it with a watch glass, and we're going to set it on a hot plate, and we're going to turn the stirrer on, and we're also going to turn the heat up a little bit. Right, so this is going to allow the saponification reaction to occur, and as the stir bar stirs, it's going to help mix the solid fat into the solution as time passes by. So we're going to check on this again in about half an hour. Okay, so now you can see after about 30 minutes of heating how the shortening has actually changed now from starting off at that solid white consistency. Now it's completely turned into a liquid that looks uniform throughout. So what we're going to do next is to add that hopefully saponified vegetable shortening into our prepared sodium chloride solution, and what that process is referred to is a salting out, and when we add it to the sodium chloride solution, we're actually going to see what happens. So I'm going to gently and carefully take the hot beaker off of the hot plate and pour the contents into the sodium chloride solution. Okay, I'll give it a stir, and as I stir it, what you can probably see is that it turns cloudy now, and what's responsible for the cloudiness is actually the precipitate, or a solid that's beginning to form, and that solid, believe it or not, is your soap that we are making. Now that I have my vegetable shortening salted out, I'm going to have to now separate the solid part of this, which is the soap, from the liquid part. And we're going to use a Buchner funnel attached here to this sink with an aspirator on it. When we turn the sink on, it actually pulls a vacuum through this side, and it'll suck the liquid out when we put our solution in here, and the solid soap will be left inside. All right, so in order to do this, first of all, we want to make sure that we turn the aspirator on, or the water on. And we want to double check that we have an actual vacuum in here, and you can test it like so. Feels about good. We're going to get our filter paper, and we're going to place it in the funnel. We're going to moisten it a little bit with some water to make sure that it sticks. And then we're going to pour our vegetable shortening soap into our Buchner funnel. So after washing out a couple times our beaker that had the vegetable shortening soap in it into the Buchner funnel, and we allowed it to separate by vacuum filtration, this is what our soap here actually ends up looking like from the vegetable shortening. So what we're going to do is to transfer some of it to a test tube to test it to see how it, in terms of the amount of foam that it produces, and also how it deals with grease. Okay, so after we've gone through and we've vacuum filtered out our soap from the solutions, this is what we end up with. So on the right side here, we have a sample of our vegetable shortening soap, and this is what it looks like. And on the left side, we have some of the soap that was made using olive oil. And this is what that one looks like. So what we've done is we've taken about 1 gram of each of these prepared soaps. So 1 gram of the olive oil soap on the left side, and 1 gram of the vegetable shortening soap here on the right, and we're going to do some tests on them. The first one we're going to do is we're going to see and compare their foaming ability, and we're going to take about 10 milliliters of just regular old water, and we're going to add it to each of these. Okay, so we have 10 mils of each of the of water in each of the soaps that we made. We're going to stopper these, and we're going to shake them to see the amount of foam that they actually produce. Okay, so on the right side I have my vegetable shortening soap. You can see its foaming ability. On the left side I have my olive oil soap. And just a reminder, when you have to shake your tubes, you don't use your thumb as a stopper, you actually use a stopper itself, so you avoid any exposure to the chemicals. So we can make a comparison here. The olive oil soap is on the left side, the vegetable oil soap there's on the right. I'm sorry, the vegetable shortening soap is on the right side. The next test we're going to do is to test the pH of the resulting solutions that we made, and we're going to use our pH paper that you used back in the acids and bases lab. And to do this, all we need to do is to just get a stirring rod, a clean stirring rod. We touch it to the solution, and then we touch it to the pH paper. All right, we're going to do the same thing. We're going to clean our stirring rod, and we're going to test the pH of the olive oil soap. Okay, and we're going to match that color up to the color on the color wheel. So on the right side here, our vegetable shortening soap. Right, if you look at the color, it's a dark blue. Color that we have, that's somewhere between 11 and 12. And for the olive oil soap, on the left side, it looks like it's somewhere between 9 and 10, somewhere in that range. Okay, and the last test we're going to do to compare these two different soaps is to see how they interact with vegetable oil, which is kind of going to be a substitute for our grease today. So we're going to add 5 drops of vegetable oil to each of the soap solutions, and then we're going to shake it up to see what actually happens. So 1, 2, 3, 4, 5. 1, 2, 3. Okay. Okay, so after shaking for about 10 seconds, after we added the vegetable oil to each of these, we're going to try to determine which of the soap or which oil or how much of the oil actually dissolved the soap in here, right? So how much soap is actually remaining in each of these? How much of the soap did the oil, the vegetable oil that we added actually dissolve? And if you look on the left side here, you can actually see some of the olive oil soap remaining here at the top, where it looks like on the vegetable shortening soap, looks like most of it is actually dissolved. Okay, so after shaking each of the soaps for about 10 seconds with 5 drops each of vegetable oil, we can make a comparison to see how much of the soap actually remains. So on the left side here, we have our soap made from olive oil, and you can see a little bit of the soap left over here at the interface. With the soap made from the vegetable shortening, it looks like it's mostly all just foam that's left over.